So, Jim, thanks for joining us. What we're going to do today is talk about commissioning, specifically how we're using commissioning in kind of a typical residential AC type of environment. There are obviously other applications for MeasureQuick in combustion analysis and some other things as well, which we'll go through some of the other tests and modes that you can do. But first off, before we do that, I think when you initially designed MeasureQuick, when you initially built it, were you thinking in terms of system commissioning, or were you thinking more in terms of system diagnosis?
Realistically, my whole thought was commissioning from day one, because if you don't get the system commissioned correctly, you really can't do much of a good diagnostic, right? I mean, it's all about, because each system sort of has its own little personality. So when it has its own line set, it has its own duct system, it has its own electrical, and once you get it commissioned properly, then you can really do good diagnostics.
And that's part of what benchmarking is, which I'm going to go down and you guys can actually see. I've got an indicator that I move around the screen. So when I click something, that blue indicator comes on, which is actually a really nice feature. I'm going to show you how to turn that on quickly on MeasureQuick. When you go into settings, you go down to general app settings. These are one of the first things I would suggest doing. I turn on show touch indicators and then also keep screen awake. I ran into a lot of issues when I allowed the screen to shut down. And then I've got loaded in here the AC normal operation, which just gives us kind of a basic set of data to work on, which is going to be what you're normally going to see if you commission a piece of equipment under normal operating conditions. So we're gonna go through some of that. But explain what a benchmark is for people who maybe don't know what that is in MeasureQuick, and I'm gonna open that up too.
All right. So a benchmark's, after you get the system completely commissioned, you go through and you got your airflow set, you got your superheat set, your subcooling set, however you're charging that system up. It's just simply a calculation of all the design temperature differences for the evaporator, for the condenser. We record the total external static pressure, and we record either the superheat or the subcooling. Primarily a kind of TXV system will record the subcooling because there's a range of allowable superheat, and then we use that data going forward to test the system. So when we store that benchmark in the cloud, anybody coming out from your company is going to know exactly how that system was set up and exactly how it's supposed to work.
Yeah, and the reason why I bring that up right off the top is because I think some people, when they think of the commissioning, it's not just a matter of doing a good solid report on how the equipment is working, though it is that. It's also so that way future technicians who show up on that site, they're going to have something to go off of, because there's a couple different pieces of data that once you set in that benchmark, it locks it in. And just to show you again on this, once we got everything set up, once we have everything the way we want it, we would hit this little plus sign, and that allows us to either save a snapshot, which is so that we can kind of show how a system's working through the different changes we're making. Say if I show up and it's got a problem with it, I could save a snapshot and then make a change and then compare those two snapshots against each other. But a benchmark would be a permanent sort of storage of this piece of equipment when it's working properly, so that now 2 years from now when a technician comes back, he can compare against that initial benchmark. And to me, that's really important when you think about commissioning, because it's more than just making a pretty report that looks nice.
Yeah, if we really get into design of equipment and we're realistically like specking the airflow, like it's maybe 375 CFM per ton to get the latent sensible split right, or maybe you've got to add additional refrigerant charge because you got a lot of length and lift on a line set, or whatever the conditions might be. We have a starting point, which is what's on the manufacturer's label, but if you really want to hone in on how that piece of equipment's, ideally tuned, then the benchmark is a way to sort of document that. And then going forward, you don't have everybody tweaking the system to what they think is the right way that it should operate. It just basically going forward, what it allows is everybody in your company is using the same baseline for performance, and everybody understands then very very thoroughly how that equipment's supposed to run, and everybody's taking it back to that benchmark every time that it's serviced, right? So it just makes it a lot easier. And then non-invasive system testing also becomes very, very not only possible but very practical when we know when we have that benchmark.
Yeah, and so another thing here, and we're not going to spend a lot of time on this, but when you're setting up a tool, one really nice thing with this is that you can go into your toolbox, you set up a Bluetooth tool, and then when that data comes out of a Bluetooth tool, it's going to show you that that data came from a Bluetooth tool, which is great because that confirms that it's not just pencil whipped in place, which we know that that happens in our industry all the time. And so the ability to see, okay, this static pressure measurement came directly from, this field piece probe that I'm holding up, that tells you that it's not just somebody putting in 0.5 inches of static, but that it was actually a measurement taken. And it's much more difficult to game a real-time measurement taken out of a Bluetooth tool than it is, something somebody writes in, which to me is critical that all these these pieces all come together, and it makes this commissioning different than somebody who previously filled out, a piece of paper and just wrote down what the boss wants to see. Did I lose you, Jim?
Nope, I'm here.
I was just saying such amazing things that you just agreed with everything I said. It's rare that happens.
I was just amazed that you finally understood what we did this for.
Okay,
I was
right.
taken back completely.
Right. What is this software for again? Yeah, fair enough. All right, so one thing that I want to show you quickly when we're looking at sort of this main screen, right off the bat, we have some really key things that are some of the most important regular things we have to know about a piece of equipment. First off, what's the refrigerant? Super important. If we want to change the refrigerant, all we do is tap the refrigerant. So that's really simple. The next is what is your baseline CFM per ton? Now, again, a lot of this is normalized based on the equipment nominal tonnage. As we know, just because a manufacturer says that something is a 3-ton unit, it's got a 36 in the model number, that doesn't mean that that is always going to be exactly 3 tons. And so without knowing the exact data from your manufacturer, there's going to be a little bit of guesswork here, but it's much better than what a technician's going to do by just winging it. And so this is one of the first things that I really like about MeasureQuick is that it has built in 350 CFM per ton for a humid climate, which is what we're in, and 400 CFM for a standard climate, and then 450 for a dry climate. And you may be even a little more than that in some super dry climates, but we find that it doesn't make as much of a difference as you think. But what you saw there, and I just did this just so you could see it, is that the targets changed. So when I went from 400 CFM per ton, you see the green target up here on the blue gauge here, it changed from higher measurement to a lower target measurement because our target airflow has changed. So I was just wanting to show that quickly. And so in our market, we would want 350 CFM per ton. Anything you want to mention about that?
No, I mean that's really important. Now, when we benchmark it, we're going to get the exact airflow, right? Because again, this thing is when you install a piece of equipment, it's going to operate in conjunction with the way it's hooked up. So you got a duct system that you engineered for this thing, and you're not going to necessarily get exactly 400 CFM per ton. It may be 405, it may be 390, it may be something between there, and you're going to end up selecting the best speed to get the best performance that you can out of that piece of equipment. And performance is a balance between obviously sensible cooling and comfort, which is humidity removal. So
right.
We do have to get it all set up initially, and then once we get it set and we benchmark the system, we're good to go.
Yeah, and one thing I like about this is that we've got the just-in-time information here on the screen. So technicians who want to understand more about why would the design airflow change under different circumstances, it's got that information right there for you to look into. And so I'm just going through the most basic things right off the bat, and then we're going to actually go through a workflow here, but just wanting to show you what's on this main screen. So obviously, we have our suction saturation temperature right here, just like you would see on a normal gauge. You have your pressure and PSIG in both your liquid side and on your suction side. And then we've got our SEER rating, and that's one thing that I think some people maybe struggle with a little bit. Talk a little bit about this screen for SEER rating, because we've got standard, we've got Lennox, we've got custom. Why does this matter, and is it important that we really nail this SEER rating?
Yeah, well, let me back up before I answer that question, because sure. You did miss one thing on the saturation temperature.
Okay, we'll back up then.
MeasureQuick, yeah, in MeasureQuick we actually show the center of the glide or blended refrigerants. And for pure refrigerants, it actually is a saturation temperature. So because we're calculating coil temperature, so we can calculate the targets, we show the center of the glide, which anybody doing like refrigeration work, they want to see what the center of the glide is on a refrigerant. And then we use dew point and bubble point respectively for the superheat and subcooling calculation. So when you look at a MeasureQuick, when you look at the saturation temperature on MeasureQuick, it's not going to agree with your Danfoss slider or something like that, because we're calculating the exact center for the condenser and then the weighted center for the evaporator coil. And that's actually, there's a whole piece on that Emerson wrote. There's a really good PowerPoint they put together. If you just search Emerson center of the glide, I think you'll find it on online pretty easily. But that's one thing we did a little bit differently than everybody else out there. So that's why it doesn't necessarily agree with Testo or Field Piece or some other gauge sets. We get that question once in a while.
Yeah, and I just changed to a TDX20 R458A just to show that that's a high glide refrigerant. Of course, it doesn't, because the pressures aren't right for that. But it's going to look at the center, and it's important because we're talking about average coil temperature, and that's actually something I talk about a lot. When you have a high glide refrigerant, you care about dew point, you care about bubble point, which are the edges, but you really care in terms of how the system is going to operate about that average coil temperature. And so initially we were looking at R410A. R410A is, it's a near azeotrope. It's very, very close to like an R22, a single component refrigerant, and so you see almost no glide. But when you get to higher glide refrigerants, it's actually really nice that at a glance you're seeing what's useful to you, which is what your average coil temperature is, rather than either the dew point or the bubble point. Even though those are there, they're just hidden, and they're used with the superheat and subcool measurements.
Right. So now on to SEER rating. You were asking about the SEER on there, and so that's again, I think the thing you need to understand when we do a profile is it's an educated guess about how the piece of equipment is supposed to run, right? We don't know exactly how any piece of equipment will run until we actually commission it and do the benchmark, because you could have a 15-foot line set, you could have a 150-foot line set, you could have 0.2 of an inch of static, or you could have 0.9 of an inch of static, and you could have no feet of lift, or you could have 25, 30 foot of lift on the line set. And all those little nuances make the equipment operate differently. And this is what makes our industry like really, really hard, because there are no concrete settings for everything. When you go out there, there's what we call acceptable ranges of operation, and it's really hard because when you go out there, first everybody tells you, oh well, just take it up to 118 and 350 and you'll be fine. And okay, that works for one set of conditions, but what about the other 10,000 set of conditions that we run under? So when you're looking at setting up this profile initially, and we say, okay, 13 to 16 SEER. Well, a typical 13 to 16 SEER system, the condenser coil will be 20 degrees hotter than the outdoor air. Now, if you look on there, we also have ones for Lennox, and Lennox tends to run a little bit higher, and so does Trane. I should probably change that to Lennox and Trane both, but they run a little bit lower
CTOA.
Design temperature difference on the CTOA than other pieces of equipment. So we're building these in eventually. And in fact, now we're going to start to store that data in the cloud, and it will actually, as you guys put in model numbers and serial numbers, we'll actually start figuring out what the CTOAs are for all the different equipment out in the industry, because we'll be able to. That's part of the beauty of starting to get big data in the cloud, is we can start to make the software better for everybody that's using it. So as you start to type in a model number of piece of equipment, we can start to auto profile the system in the future. That's ultimately what the goal is. And right now we just have to make we have to rely on you to go through and set the profile, and if it gets the profile right, it's going to get you in the ballpark for where the pressure should be. But typically when you see, like in the diagnostics, just like a low suction pressure or a high suction pressure or a low head pressure or a high head pressure but no other symptoms, that's typically just means that the profile is not quite right for that piece of equipment. And once you set the benchmark, it'll adjust that design temperature difference to what it actually is.
Yep, and that's the point, is that once you hit that benchmark, once you've benchmarked it, now all of your ranges move to the center, basically. And they're going to now track with changes in ambient conditions or changes in system load, accordingly. And that's a really nice thing. And so you're not now using guesses. You're comparing the equipment against itself, which we've all
Right.
done this. We've all done this for years. If you go to a facility that has multiple units, let's say you're working at an apartment complex, you're working at we do a lot of self-storage where you have a lot of small units. You're comparing one unit against all of the other units, and so that helps you to establish what normal looks like. And that's essentially, you're doing the same thing in those cases. You're just creating a benchmark based on other equipment. Where even better is to create a benchmark against this piece of equipment, so that way 2 years down the road you go back and you check it and you see, well, now the subcooling is lower, or the superheat's higher, or the superheat's lower, or some sort of significant change that again is still tracking with changes in ambient conditions, because it's not just one number. I think newer technicians get this wrong sometimes. Obviously, you go to a space where the ambient conditions are different, one day to the next, then it's going to change the pressures and it's going to change some of the measurements. But this, in MeasureQuick, it allows that target to change along with those conditions.
Right, and it's really cool. I mean, as long as the equipment doesn't get dirty, right, it's going to track that really, really well. I mean, it'll track it right to the PSI. Now, the thing to realize too is, like, when we do a benchmark on a TXV system, we deadlock in the subcooling, because the subcooling really is not going to. It may change a half a degree to a degree over different load conditions, but it doesn't change tremendously. But your superheat, on the other hand, depending on where that line set's located, and it could be through a hot attic, and it could be a range. So on a really low load day, you might have 10 degrees of superheat. On a high load day, you might have 24 degrees of superheat. So, while we lock in the subcooling number, we allow a wider range for allowable superheat. And then what we're really watching at that point is to make sure that the suction gas stays below 65 degrees, so we get adequate compressor cooling, right? So,
right.
Just because you do a benchmark doesn't mean that all the variables are going to lock in. We lock in airflow, we lock in static pressure, we lock in pressures, we lock in the superheat of the subcooling, but there are a lot of things that are a function of the load too, and those things will change with the load, indoor and outdoor.
Before I forget, I wanted to show quickly. This is while we're on the screen. If you click you hit the MeasureQuick logo on one of the gauges, then just that gauge will pop up to make it easier to focus in on. But I kept missing how to get back, and all you do is you just tap on the MeasureQuick logo. You can kind of see what I'm doing with the indicators there. So if you ever get in that screen, that was something I screwed around with for half an hour before I finally asked Jim, and he called me a dummy, which wasn't very nice. But I deserved it, I imagine. So let's move forward into one thing that you can do, and this is just sort of in more of the diagnostic screen. We're going to go into a project now, but when you swipe back and forth, you can change what readings show up on the screen, and it'll kind of scroll through. You see we have the eye icon, and then the sun, which is outdoor measurements, then the house, which is indoor, then electrical measurements, and then weather conditions. But just by swiping, you can see my finger swiping across. We can do essentially the same thing, or we can tap those little indicators, which is just a really nice user interface piece there.
Yeah, and there's two dots, meaning above the input boxes, meaning there's two screens. And then a lot of people still don't know that you can tap on those square boxes, and those are input boxes. So, like if you go to the indoor readings, Brian, just tap on indoor and you open that up. So now you can see all the indoor readings, and you can manually input an airflow or something if you want to, or you can see what readings the probes are coming off of. But we did that to clean up the UI, because obviously if you've got all the probes connected, you don't need to see, all those readings coming in on the UI. You can just look at them, look at the calculations on the display.
Right. Yeah, and some of you are going to like these sorts of interfaces more. In fact, I spend a little more time in these sorts of screens, but it's still nice to come back to this display because visually it's great. And for those users who are very new to it, you find that a lot of them are just taking screenshots of these things and send them to their boss, which is totally fine because it shows the ranges and it gives you a sense of what's acceptable and unacceptable, which for a newer technician is a nice thing. But for those who want a little bit more advanced, they want to get a little deeper into the data and change it, edit it, you just click that box as you saw me just do there. So I want to go now. If you think do you think it's okay to start going into an actual project so we can see how that flow works, Jim?
Yeah, I think that's good. I mean, the whole concept of MeasureQuick initially was to do commissioning, like we said. So the idea is we set up this project and we go through the steps of it, and then we commission the system, and then we store that data in the cloud so we can get to it later on. And by the way, there's no charge for storing anything in the cloud. If you just use MeasureQuick and you don't pay us a nickel, you want to store all your data in the cloud, and 2 years from now you want to go pull a job down because you just have some questions about it or whatever, you wonder how it was working, you can pull that job back down. You'll pay for it then, but there is no charge to put data up in the cloud on MeasureQuick. And in fact, everybody, by the way, if you update your cloud account, you got $20 of qubits for free on your account right now, so you can use it for report generation if you want to test out the advanced reporting, or you can stream data with it. It's very inexpensive to stream data, so I mean you could stream hours of data on what the credits we gave you, or you can just add your own logos or whatever. So you just go to MeasureQuick.com and then log into your accounts. It's your MeasureQuick username and password, and then you can see what's going on there, and you can just update your account information, and it'll load the free bits on your account. So.
Yeah, great. And a lot of that is changing as we speak. I mean, if you use MeasureQuick regularly, you know how often it's updating. All of this is continuously being improved and changed and to make it better and easier to use. And I really like the business model moving forward. So let's go quickly. I actually want to click. I'm going to hit this little like radio button over on the. Oh, wait, that's not what I wanted to do. No, I'm going to hit the little graphing button to the right of the X. So if you watch my indicator here, there's a little graph here next to the X. I'm going to hit that because I want to show quickly how we get into the basic mode. So first it's going to go into a trending mode. But if I hit to the right of this, it's going to go into the system vitals mode, we talked about this on a recent podcast, and I just wanted to show this to you. It makes a really simple view based on the data that we've already entered. We've got subcooling, we've got supply air temperature, low pressure, high pressure, superheat, and approach. And then you can also do the quick charging mode there, which is helpful for newer technicians to actually indicate how much refrigerant to add or remove based on the measurements that you're getting, which is pretty cool. Now you already, again, I keep going outside of what I keep saying we're going to do, which is going into setting up a workflow on a particular piece of equipment, but I really like this for newer technicians, so that way their eyes are going immediately to where they need to be focusing.
Yeah, why don't you start a workflow, Brian, so we can see how that's done?
Okay, let's do it. I'm going to hit the plus, and then that's going to open up. Wait, no, I did that wrong. Sorry.
Hit the project
Button. That's what I meant to hit. I knew that. I was just testing you to make sure that you knew how to use your own software, Jim. I'm going to hit the project button, and then we're going to go to AC or heat pump cooling. So if you look at my indicator here, I'm going to AC heat pump cooling, and I'm going to start blank. Now I can also use cloud data. This is one of the options here. So tell me about that. Why does it say use cloud data? What does that mean?
So if you've stored a system in the cloud before and you want to just start the project from the cloud and not have to type everything in, or if you have actually if you had a Service Titan CRM, it'd actually be at the top. You don't have to use cloud data for that, but basically it just allows you to get all the data pre-populated. So once you put it in MeasureQuick once you set up this project, you get the model numbers, you get the serial numbers, you get the benchmark in, you got all this set. You literally, when you start a project from the cloud now, all you have to do is deploy your probes and wait for the system to stabilize. So you can literally, if there's nothing wrong with the system, you can do a tune-up in 10 to 15 minutes, because that's about all the amount of time it takes for the probes to stabilize. It'll give you the green flag. You hit capture data, and you generate the report, and you're pretty well done.
When you say do a tune-up, you mean after you've done your cleaning and all the other things you're supposed to do?
Right.
Okay.
Right, correct. Right. I said if there's nothing wrong with the system, right, so it's clean, the filter's good, right? And I'm just saying that to go through and actually retest the system takes almost no time at all. And so once you have that benchmark in, now that the diagnostics are really, really accurate, because we know where the pressure should be exactly. So we know what's high, we know what's low, we know if things have drifted off. And one of the things we'll talk about later is sensible cooling, how important it is to watch that. So I'll talk about that when we get into the performance section. So don't forget to go there. But yeah, let's get back into the project.
Right. And what you mentioned is also when you do those tests, a lot of times you're going to do those non-invasively. And that's also where having benchmarks come in really handy, because it's tough to do a non-invasive test unless you have prior benchmarks. And that's where using cloud data makes sense. And that's where having somebody previously gone in and created a benchmark on that equipment is great.
Oh, and one more note on the cloud, Brian, before we go away there, is we only pull up data within about a quarter of a mile of your location. So, because once you get like 1,000 systems in MeasureQuick, you don't want to hit use cloud data, have to scroll through 1,000 systems. So what we do is we use geolocation, and we pull up the ones that are close to you, and then you select the one that you want to use. So right now you can, I don't know if we have, actually, so next week we should be pushing out an update so you can go in and pre-populate your projects on the cloud. If you put them in and then you go to look for them, they may not be there because you may not be within the location of the project. So right. Just so you know how that works.
Got it. Okay, I'm going to show this again because somebody requested it. I'm hitting AC or heat pump cooling, and now I'm going to start blank. So now we've got to go through and we've got to populate all this information for this particular location. So we can name the project whatever we want. We can add some. We're going to start by adding some details about the project. We can add notes for the project here if we want. And so we're just going to type NA here.
You notice that note field is really big now too, Brian, because we increased the size of it because in the premium projects you can take a whole page if you want to put a whole page of notes on.
Yep. And then job site, that's where you add your contacts. Right here, it's pulling up my home address. If anybody wants to send me hate mail, this is correct. So, anything like that, maybe a horse head in my bed, this is an option here. And so go ahead.
Important note, there's a site name and automatically came up site 2, and you're going to want to sometimes change that name to like, your residence or whatever you might want to change that site name to, because what that does for you is when you go in the cloud and you search for things, you can look at it by site name instead of by nothing. So site 2 may not mean anything to you, I guess is what I'm saying. So you can actually edit that. Now, here's the other catch-22 of that, and the reason we automatically name sites and automatically date and timestamp is so that if you were to get a phone call or MeasureQuick were to crash, or you were to drop your tablet or whatever could happen, we're always saving that data in the background so you don't lose your work. So if you were to completely close MeasureQuick and open it back up again, you're going to be right back in the project that you started, and so we have to put in some names so that we can store the project.
And also another thing that I was just showing people is that you can move the pin location. So say you're on a commercial site and you've got equipment in different places around the site. You can actually specifically place the pin exactly on top of where the equipment is located, which is super handy.
Well, there's 2 pins too. One's for the site and the other one's for the equipment.
Oh, okay. All right. So I was moving the wrong
So right
pin.
now you're just going to mark the site, where you want the site general location.
Got it.
Right.
Okay. All right. All right.
Yeah, that way it grabs the right Google address.
All right. And you can go in and add the information for the particular customer as well. And once that's done, you hit submit, and now we move on to the equipment information and system profile. This is where it starts to get into some of the specifics of the system. And now this has a specific equipment location. This is what I was talking about. So my condenser in my house is right back here, in case anybody ever wants to sneak up to my house and wash my condenser for me. And I can then name this particular unit. So I assume this name is specific to this particular unit. So I'd say, AC
right.
number 4 or whatever.
You can zoom in on the map too if you want to pinch and zoom or whatever. You can do that too, just so you know.
Okay. And then we can add our information on the equipment. Now, this also allows you to scan a barcode. And tell me a little bit about that. Does that work with everything, or is it limited to certain brands?
No, it works well. So it works with everything. It just depends on what the manufacturer puts in the barcode what it pulls up. So like if you scan, Goodman uses QR codes, and if you scan a Goodman QR code, it'll actually pull in Goodman, it'll pull in the model number, and it'll pull in the serial number, all three of them, because believe it or not, Goodman probably does the best job of using QR codes of everybody in the industry. Other brands, like I think it was Carrier or Lennox, when I scanned the barcode, it would actually pull the model and the serial number in on the exact same barcode. So you had to delete half of one of the others. So, you scan it once, delete the serial number, scan it again, delete the model number part of it, and then, type in the brand name. But depending on what you work on, it could be a little bit hit miss, but the barcode scanner, the QR code scanner works really, really well. Some manufacturers, like Rheem, they only barcode their serial numbers, but as manufacturers do more and more of that, we'll figure out better ways of utilizing it. And then also, obviously, there is a photo there, so take a photo of the data plate also. So in case you ever got to reference that later, those photos will always come back up with the project in the cloud. They're stored in the cloud. So you'll want to make sure that you capture those as you go.
Yep. And one question I had, the AHRI certificate number, does that do anything right now if we enter in that AHRI?
It does not yet. AHRI decided to raise the price of AHRI to like $9,000 a year for that database access. So until we had it all set up, and then we decided, well, until we had the cloud out there and we could use it, we weren't going to repopulate it. So now we're going to go back through and reload all that data on the cloud. But I just want to get enough users up that are interested in that before we go spending $9,000 on something that people may or may not use. So, right. But it does it will work. What we're doing is actually a little bit different. We had it set up so that we could actually do a reverse search. So if you put in the model of the condenser, the model number of the air handler, the model number of the evaporator coil, we could actually tell you if that was an AHRI certified system, and then print the label. And we had I can't remember, they think called a Boolean search or something crazy like that. Very complex to do, and it was one of the things we were trying to do was improve that, because so many guys get in the field and they can't figure out what the certificate number is. So hopefully we can get that back up and running again, but we just got to get more users on the software that are paying for services so we can do that kind of stuff, because it's if nobody's using it, it's just a cost that nobody wants. That's mainly me.
Right. One question that's come up here a few times in chat is people are saying that saving more than one photo, they're having trouble with it. Is that are you able to save more than one photo, or are there some questions?
Not on
about
the
that?
model and serial number plate, but on the premium cloud features, you can store like 40, 50 photos on a job report. So okay. If you activate the project there, yes. And then what we're doing is those photos get stored on an Amazon web server. Then we just call them up when we call them back in, because photos take a ton of memory. And that's part of why we had to start charging for things, is because, obviously we need to make money too. I guess everybody wants to make a living, but when you start getting it intensive with a more detailed reporting and storing projects and storing, photos, then it started taking up a lot more space on servers. So we had to put together stuff to manage all that, make it so that the app works really fast and doesn't get bogged down with a lot of pictures and things.
All right, so we're going to move into the system profile now. So first option is system configuration, whether it's split, heat-only package, or mini-split. That's pretty obvious. Next, we put in the nominal tons. So whatever the rating plate tonnage is, that's pretty basic. And refrigerant, we already talked about. Nominal airflow, we already talked about. 350 CFM per ton being the standard in hot and humid climates, 400 being standard in most of the country, 450 for drier climates. You enter the SEER rating, you enter the metering device type. All of those are fairly obvious. Now let's talk a little bit about high efficiency or oversized evaporator. That is a toggle button there. What's that all about?
Yeah, so a lot of climates, people are, well, actually, not even climates today do that, but a lot of times people are oversizing the evaporator just because they want to get additional either efficiency out of the system, or they want to minimize the amount of static pressure drop across the evaporator coil, right? A bigger coil has less pressure drop. So a lot of times there's many reasons people might select a larger evaporator. But what happens is with the larger evaporators, it drives up the suction pressure. When you drive up the suction pressure, then you turn around and the coil's warmer, so now you end up not dehumidifying as well. So then what you may have to do is select the oversized evaporator coil, but then slow the airflow down. So I imagine like in your area, Brian, this is pretty common. You guys oversize the evaporator, then drop the fan down to 350 CFM per ton. And then that runs pretty typical, about a 40-degree coil on the system. Runs just like you would a regular system. The other note is, if you scroll down just a hair further, Brian, is there is extended performance data where you can put in an exact BTU of the appliance if you know it. Otherwise, just go off the nominal, and that'll be close enough.
Right. So it gives you the ability, if you want to be a crazy nerd like Joe Shearer, to enter that in. Otherwise, for the rest of us, I saw Joe in there. You've always got to give him a hard time. All right, so below that, so high efficiency evaporator coil, the way we do it at Kalos is I tell our installers when they're going to commission a piece of equipment, or we have one commissioning tech who does most of the really advanced systems, that if the coil can serve a larger tonnage, because this comes up a lot with like carrier fan coils, where you might have a fan coil that can serve multiple tonnages. If that coil can serve a larger tonnage than what it is serving evaporator coil wise, then use the high efficiency oversized evap number, and that we find to be quite accurate. On superheat, subcooling, total external static pressure, these all have like a target symbol on the left side there. What is that all about?
So that's your target superheat, your target subcooling, your target total external static. So typically, when we're doing superheat, we target 10 to 12 degrees of superheat on a TXV system. Now we get the manufacturer's target superheat or subcooling off the label, right? And then obviously total external static pressure. If you know a design target, like typically a lot of guys will design for half an inch of static, but some guys that design it for lower. Some air handlers have lower static pressure, so they might go down to 0.3 of an inch or something like that. And so what you're doing is just if you know what the target is, put the target in, and that'll do that. And somebody had asked too, if you're in MeasureQuick and the app closes, as long as you see that little exclamation mark down by project, that's a little black box. A lot of you guys are looking at it. You probably can't see there's a mark in it. As long as you see that mark, you're in a project, and as long as that's open. If you close the app and you come back in, even tomorrow, all the data that you put in is going to be there, and until you submit that project, so you don't lose your work that you've done. If data is streaming in live from your probes, obviously the data will go away for a second until the probes reconnect. But as soon as the probes reconnect, you're going to get your data right back in. And then another thing people sometimes mess up is they capture data and they don't clear it. So there's capture buttons on some of the screens. Like if you got out of probe range, I just had a guy call me yesterday. He's like, it's not reading right. It's different. And I'm like, okay, go into outdoor measurements and hit clear. And he goes, oh, that fixed it. Okay, I forgot I captured those measurements. And, so there's a couple little things you got to learn. But once you're past those, you're good to go. All right, so let's keep going on this, Brian.
You said something about people being upset when their data goes away. That happened to me at a very young age. I've been trying to get my data back. Never mind. It's really bad dad joke. Okay, keep going.
Just like you started this project blank, and we can go there too if you want.
What do you mean?
You've probably started a lot of projects blank anymore. So.
I do. Okay, so you enter. So superheat on a TXV, you're generally not going to edit that unless you know there's some reason that you need to. Subcooling, you're going to go based on what the manufacturer data plate says. If it's superheat on a fixed orifice, well, that's going to be a moving target depending on conditions.
Right. So why don't you change the metering device real quick, Brian? Just change it from fixed to TXV or TXV to fixed.
Okay. So we're going to go to a piston. All right.
And then you'll see the superheat's calculated. So
right.
So we do a lot of this stuff automatically for you, so you don't have to worry about it.
Why did our subcooling target go to 20 when I went to piston?
Because you got to have some subcooling. So, 20 is a pretty typical range for the older piston type systems. So it could go, as low as you'll typically always have about 10 degrees of subcooling on those. But depending on the day, because the refrigerant migrates all over the place on a fixed orifice. So if you think about it, some days you're running 25, 30 degrees of superheat. And then other days you're running 5 degrees, right? So you can have a bunch of refrigerant in the condenser, and you're running like 30 degrees of superheat when it's 68 degrees outside. When it gets up to 120 outside, you might be running almost 0 degrees of superheat or subcooling. 0 degrees of subcooling, and because you're running really, really low superheat. And so it just moves the refrigerant around, and so you got to have a wider range for subcooling. Otherwise, it would show you're outside of the target range all the time.
One question that somebody had is, why do you show capillary tube and piston? Wouldn't they behave the same?
They in theory they would, but capillary tubes take a little bit longer to stabilize than a piston does when you're talking about the refrigerant charge. So we run algorithms in MeasureQuick so that we know what when the system's stable, and if you got a capillary tube, it's going to take a little bit longer to stabilize than a fixed orifice will. And then also, like with a EEV, you notice we have a separate one for EEV, and we run a tighter tolerance on the superheat range there. Instead of ±5, it drops to ±3. So it just depends on what you're working on. We take a lot of the characteristics into account so we can make software work as fast as possible.
All right, and so if you hit the plus button next to refrigerant charge, that opens up and it asks you for factory charge, and then it also says charge added or removed.
Right. So you can actually store in, and what's cool with this refrigerant charge, you could put in 5.25 pounds, 5 pounds 2 ounces, 82 ounces, any way that's on the label, you can just type it in on the display and it'll work in MeasureQuick. So we put a lot of logic in that to make it easy, and this is just storing the factory charge plus or minus whatever you add or remove to the line set, so that we can get a total charge. And eventually, we're going to make some additional pages on the commissioning report that'll have a lot of the extra data we're capturing right now, like filter type, line set length, fuse size. We're on the electrical, we're grabbing the capacitor sizes and things like that. So it's just right now, we have the generic report out, but we're building the framework so we can make, tie in additional data for later, so that when you go out to a job in the future, you'll have a little bit more intel about what parts you might need, or what filter you're going to take out, or what caps in that unit, or what kind of refrigerant, how many pounds, or whatever you want. So it's all going to be there.
Now, one thing here underneath there, it says retrofit refrigerant used, and it has a checkbox there. What's the purpose of that?
So that's if your system is an R22 system and you're taking it to Bluon or 407C or whatever, so you can mark that it was a retrofit. It's not the refrigerant that system was designed for. We haven't done anything with the performance calculations, because some of the gases do have pretty significant performance drops. But we're just trying to capture as much data as we can so that we know how that piece of equipment is supposed to operate. And again, when you pull down the benchmark from the cloud, because we're storing the refrigerant type, when you're sending somebody out there to look at the label and it comes back Bluon 458A, they'll know right away, okay, it's not R22 in this system if they're restoring from the cloud. But it's just additional things to help out going forward.
Whenever I ask you a simple question, if you go off for 15 minutes with every answer, this is going to take for 4 days.
Well, that switch is for you, Brian.
Okay, good. That's all. Just for people like me. All right. So then below this, we've got our extended performance ratings, which I had already opened up, and so we can close that back down. It also has the heating profile, so I can choose what the heat type is, and then that'll give us some additional, but we're not going to mess with that right now because that's not what we're talking about today. All right, so after we get all that system profile done, now we go into installation information. So it asks us line set equivalent, line set location, line set lift, liquid diameter, suction line diameter. Is any of this used in a particular way in the software, or is this just for reporting purposes?
No, actually, line set length is definitely used for correcting capacity calculations. So we normalize capacity calculations in MeasureQuick. And one of the things we do is the longer your line set, you start to lose capacity. So we take line set literally up to the foot into account. We take into account the filter sizes. So actually, in the performance section, it'll calculate. On the version coming out next week, it'll calculate filter face velocity, and Then it stores a filter in there, and I don't think there's anything else in there that's really relevant, but yeah, line set lift also falls into the capacity calculations. And I think those are the big ones. There's also a belt calculator in there if you have a broken belt, don't know what size it is, and a couple other things. But for the most part, yeah, we use almost everything we collect to do something, but some things are not yet.
Yeah, there's a lot here, and again, I think it potentially serves two purposes. One purpose is the obvious one, which is you may need this information later, and this serves as your reference report. Think of a manager who wants to later go and find out all the information on this piece of equipment. If they're playing ball with MeasureQuick and they've enrolled in the program and they've got the software, they can go and find this later, which is super important. But then also some of this data does actually play into some of the normalization, like you mentioned.
Yep.
All right. So once we get all of that done, this looks like we're done here according to the report. What's next? We did system information, profile, installation. Oh, electrical. So we've got electrical here, condensing unit, phase, single or three phase, nominal voltage 230, 240, evaporator fan phase, evaporator fan nominal voltage, evaporator fan type. It also asks about capacitors. So why would we put capacitor information into this?
That's so we know what's there when we come back out later. Also, if you had a hard start kit installed on there, so we capture that data. If you have an aftermarket start assist on there, but primarily just also on the evaporator fan, if it's got an ECM, we ignore the power factor because we can measure power factor with a redfish meter or with a field piece 380V. So you need to know the power factor should be close to 1. So, but on an ECM, it could be like 0.55. So we ignore that.
Right.
And then also on the PSC motor, when you're going into that vitals mode, we tell you, to increase or decrease your airflow, what speed you need to move it up or down to. So there's some things there we use on that. But and then on voltage, we're looking for well, not yet, but it will in the future. Look at utilization voltage and tell you if you're in the correct range for the utilization voltage and some things like that. And then it also uses it for power factor. So for an assumed power factor, if you don't have a meter that measures power factor. So a lot of little things in there that voltage plays into.
Got it. All right. So we've touched on everything. Of course, we didn't fill out a lot of it, but now we're pretty much good to go on this part of it, on the actual project part. So now I can go down and hit submit. Now we move down into equipment information and system profile. Oh no, sorry, we already did that. Hold on. Now we go into take measurements, right?
Yeah, it's just you didn't have your system information filled out. So this is important too. You see I got the X there next to system information. And it's just because you didn't fill out the models and serial numbers. So it's looking for those and you don't have them. So let's go into measurement section.
All right. So we've already got checks on all these because I've pulled in some data, but we're going to go into outdoor measurements, and these are the actual ones that you would fill in. So this takes a very logical, I want to state this again, and for those of you who are worried about this, we may go 15, 20 minutes over on this because we got a little bit of a late start, as I have been doing because of technology issues. But this is the logic you're going to go through. These are the readings that you're going to take, and these are manually entered. But in most cases, we're going to want these brought in from the Bluetooth connected tools, which you do by going in the toolbox, assigning tools to different measurements, that sort of thing. Anything you want to mention about any of these outdoor measurements?
Oh, I think the key thing is sometimes people call us and say, "Hey, how come this reading's grayed out or whatever?" Right? So like target superheat's a big one. People say, "I don't have a target superheat; it's black and white." Well, it's because you don't have an outdoor air temperature in, or you don't have a returner wet bulb in. So if there's a reading we need to calculate something, we're telling you in the UI, hey, you don't have this, and you can't really get the correct reading unless you give us this information. And the other cool thing is you don't have to break the bank. If you own a handful of probes and you want to use those in MeasureQuick, you can use those, and then the other readings you can manually input. So it's not like you have to have everything or nothing. You can use what you have and then add to your toolbox as you go, and eventually you'll find out, boy, you want to have everything streaming data in because it's so much faster. but it's not required. And if you're in a trade school or whatever, your kid learning, and you're using analog gauges, you just want to use the diagnostics, you can input all the data by hand. The challenge with inputting data by hand is obviously, you can transcribe it, you can put in a wrong reading, whatever. So the probes make it exponentially easier, but we built it that way so anybody can use it with whatever tools they have.
Yep, absolutely. So it's functional with anything. We prefer that you're using, well, when I say we prefer, I mean, I think business owners would generally prefer that you're getting real data. I know customers would prefer it if you're supposed to be doing a true commissioning. But all right, so this is your outdoor measurements. These are really obvious things, standard things. They can be brought in by your Bluetooth tools. Let's go to our indoor measurements now. And indoor measurements, these are the ones, and I struggle with this even with my own technicians or my own installers, I should say. Technicians are pretty good about it, but they don't want to deal with with the wet bulb of the return. They're not used to putting the psychrometric probes in the supply and the return. Sometimes placement's a little tweaky. But I mean, this is where a lot of the rubber meets the road.
Oh, for sure, yeah, because these are the measurements we're going to calculate capacity with. Now, the cool thing is you only have to put in 2 of the readings. So if you put in supply temperature and humidity, it's going to calculate wet bulb. If you put in wet bulb and humidity, it'll calculate return dry bulb. And any one of the 2 will calculate the third variable. So you only need 2 of them coming in. And then the other thing you're going to see there is our estimated airflow calculation, or you can put in a measured CFM. Now, if you put your probes in properly, the estimated CFM and the measured CFM will be very, very close together because that's a mass flow calculation. It's based off of CFM per ton, and we've tested that at the National Institute of Standards and Testing against 4 or 5 different metrological grade instruments, and we were consistently within 3 to 4%. There's been a lot of guys that tested this over the years. It does require some of your probes, it does require like your liquid line temperature probe for the highest accuracy, things like that. But you can use that as a primary measurement method if you don't have a capture hood or you don't have a true flow grid, or if you want to measure your airflow, you can. Either one will work, but I almost exclusively use estimated airflow just because the speed of it. So.
Yeah, and this is, if you're going to do point to point, it allows you to add grills and remove grills and that sort of thing as well. Of course, it didn't actually respond when I just did that, so I don't know. But that's part of it. But I really don't suggest that method for a commissioning. And then one of the reasons is that duct leakage comes into play there. For commissioning, my 2 only really good ways that I like to see people do this are using a manufacturer's chart and static pressure, or using a true flow grid. Those are both things that an installer technician can do in the field. But now that we have this from MeasureQuick, while it is still an estimate, like Jim mentioned, it's as long as you put in all your data correctly, it's actually a really accurate and reliable total system airflow estimate.
Yeah, and another note on that is, if you use another measurement method of measuring airflow and you find out, because a lot of guys say, oh, your measurement's too low or it's too high or whatever. Most of the time people say it's measuring too low. Well, what usually happens is they have poor probe placement, and
right.
It's too close to the evaporator, and it's seeing line of sight of the evaporator coil. And so when they put in their airflow, they're going to get capacities that are like, if it's a 5-ton system, it might be doing close to 5.5 to 6 tons of cooling because they're getting this ridiculously high change in enthalpy because the probe placement's poor.
Right.
And it's not a function of MeasureQuick. I don't care what software you're using. If you don't put in the probes in the right place, you're not going to get a correct change in enthalpy. You're not going to get a correct temperature drop. So this is just good practice in general. And we always recommend first supply run, inside the register. Always go up inside the register with the probe tip, because if you're in the face of the register, you might get entrained air. That causes it to get like a mixed air reading instead of a supply air reading.
Yeah, if you're working with fan coils, you're going to be safer because you're over top of the blower, not over top of the evaporator coil. But you're right. Placement of probes where they're affected by any sort of cold or hot surface is going to be a huge no-go. It's going to give you a lot of false readings, which is the reason why a lot of the ways that people have traditionally measured airflow aren't really great, both because of turbulence and because of potentially being line of sight to a radiant temperature that's lower or higher than the actual air temperature. The next thing here is that it gives you the ability to actually have a measured return in supply static pressure, which it's great for these new field piece probes. Are probably I've just been testing these out. These are going to be a really great manometer to use for this, because you can independently check your supply and return static pressure, which gives you a picture of where the problem may be.
Yeah, we're actually building out a whole new algorithm for those to do static pressure testing. That's going to be a 4-point static pressure test. So you'll test in the return, after the filter, before the coil, and then in the supply duct, and it'll actually do some testing and tell you where your static pressure problem is in your duct system and what you need to do to fix it.
Yep. Yeah, that's static pressure is huge. It is a really useful measurement, even if you're not using it to get total external static for the purpose of calculating airflow. It's still super useful because it shows you where your problems may exist, especially when you're above your total external static number that you should have. Your drop across your coil, your drop across your filter, those are all things that are super helpful to know so that you can diagnose where a problem may be. It's more than just that total external static number, because once that number is higher than the target, now you need to figure out what the reason for that is. All right, so now once we're done with that, we hit submit. Then we've got electrical measurements. You've got voltage L1 to L2, amperage L1 or L2, power factor. Same thing on your condensing unit. You enter all of those. Now, what happens, because I think this is one of the first questions that people might ask, is what happens if they don't have a meter that measures power factor?
Then just use the default 0.95s, and we actually have different ones for 3-phase. So it depends on if you had 3-phase, it might be like a 0.85 or something like that. But you can just use the default 0.95. It's a little bit conservative, but it's some people say it's typical. I'm seeing more and more of them at 1 now that I got the redfish meter. Everybody used to say, 0.95, 0.9, 0.96, whatever, and I'm seeing so many at 1. If you have a good cap on there, it's ridiculous. So I tend to use that more than anything. But then you can just input it's either phase to ground or phase to phase or power directly, and if you're using the redfish meter, it pulls in all of them at once, one measurement, one click. We will get the field piece meters in pretty soon. I think, though, you're going to have to rotate the dial and capture on that, because it's only got a couple readings on the display. So we're still working through the details on that. So I thought that was going to be a quick integration, but because of the way the meter's made, it's going to be a little bit more challenging, but it should be out this month. So.
Yep, and that's your main measurements that you're gonna enter there. You also do have phase to ground. Do you want people entering that every time, phase to ground?
No. It's just a matter of however you make your measurements is how we'll do them. So, like I usually measure phase to phase. Some people measure phase to ground. Some of your meter, like when we get into utility clients, sometimes they want phase to ground because each phase is independent. It just depends.
Got it.
So.
All right, and then we get into the all glorious performance calculations, and this is something that you wanted to talk about a little bit on the, you're really harping on Sensible lately. So we've got these capacity calculations on screen. First off, let's just talk about what each of these are, because I think this is helpful. So you got nominal. What is nominal?
So nominal just means normal. So it's your if you say a nominal 2 tons, that'd be 24,000 BTUs. But the key thing is that a 24,000 BTU unit really never does 24,000 BTUs of cooling, because it's very rarely at AHRI conditions. So what we do is we normalize the capacity. So in other words, what do we expect from that 2-ton system? Well, we take into account the return air, wet bulb and dry bulb, the outdoor air temperature, the line set length, the voltage, all those things, airflow, they all attribute to how much cooling we're going to get out of that thing. And so we normalize the capacity. So under the load conditions you're at now, if it was the 24,000 BTU nominal, we expect to see 21,000 and 931 BTUs, I guess, is what's on your display there.
Yep.
Right. So now the next thing is, well, what's our ratio of sensible to latent? So a portion of the air conditioning is designed to cool the space down, and a portion's designed to dehumidify. Now, we're always going to get the sensible cooling out of the machine, right? Now, the sensible cooling will go up and down because our temperature split goes up and down, right? We could have a 16-degree temperature split on a really humid day, and we could have a 25-degree temperature split in a dry climate like Arizona. It just depends on the amount of latent load we have. But what's interesting is that the amount of latent cooling we do depends on the amount of humidity that's in the air, the amount of moisture that's in the air. So we can have a system that's in Arizona that's doing 100% sensible cooling. The sensible heat ratio is 1. In other words, 100% of the cooling we're doing sensible, and we have latent capacity available, right? So if we had it set up for a 0.75 sensible latent split, in other words, we engineered it so that 25% of the energy was going to cooling the home and 25 was reserved for dehumidification. You could have a unit in Arizona that's doing 100% of its sensible cooling, but the reserved capacity for dehumidification is doing nothing, and that system is running perfectly. And so you'll see that your actual capacity looks low. It would be 75% of the rated capacity, but the machine's running perfect because there's just no humidity removed. So if you're in Arizona and you're trying to show this to your customer, you're going to show them our sensible capacities at 99, 98%. Machine's running perfect because the humidity, again, that latent load just depends on if you have it to remove or not. So that's a really important thing to understand. It took me a long time to get that. And when you optimize system operation, you should always optimize for sensible cooling because that's what satisfies the stat. So we want to have as much sensible cooling as we can while still controlling the humidity, right? That's the important thing to remember there is that we optimize for efficiency and then adjust it for comfort, right? So in Brian's climate, you may do just the opposite because in Florida, they're really concerned with the humidity more than satisfying the stat, right? Otherwise, you guys get growth. So,
yeah, and that's why in order in a dry climate to optimize for sensible capacity, you do things like really drive down your compression ratio as much as you can. You use oversized evaporator coils, and you run high airflow, and you do everything you can to optimize your compression ratio to be a little on the exotic side. But what you're saying is very true. Is that you have this standby latent capacity that if you don't use it, it's not like you can just recover it. And I'm going to I have a short podcast I'm planning on doing this week to talk about exactly why that is, because it's a little bit complicated to understand, but just know that that's the case. And looking at your sensible capacity is going to be huge when you're in dry climates, and when you're in humid climates. You really want to look at what your latent and sensible heat ratio is, because if you have too high of a sensible heat ratio, not enough latent removal, well, you're going to have people who are uncomfortable because their humidity is too high. So I think it really depends a lot on what your particular climate is.
Yeah, and if you get the podcast done on time, then we'll say you got to the dew point quickly.
I see what you did there. I got to the dew point. Everybody's just laughing their rear ends off right now. All right, so airside performance. Okay, just to clarify again, nominal is just normal. Normalized is it's adjusted for the current conditions as opposed to AHRI conditions. Actual is what we're actually seeing. Sensible is the heat that changes the thermometer, that actually changes the temperature of the air. Latent is the moisture removal. Now we get into airside performance.
And
first off,
don't forget sensible heat ratio, because that's the ratio of heat to humidity removal.
Right. And so
right.
a lower sensible heat ratio is better for when the climate is high latent. So and that will naturally happen too. When it is more humid in the space, you are naturally going to see a lower sensible heat ratio. But we also want to see that number be low when we want to remove moisture. So it's kind of a hand in hand thing.
But if you can't compare sensible heat ratio and MeasureQuick to the manufacturer's table, because we're calculating the actual sensible heat ratio, which changes with the load conditions continuously versus a single set of design conditions that are in the AHRI.
Right, which are based on AHRI conditions, which are very unrealistic anyway.
Right. All right. So now we got airflow nominal, and nominal airflow just means, in your case right now, you have a 2-ton system, 350 CFM per ton, so we're at 700 standard CFM. And you'll see two types of CFM in MeasureQuick. One is SCFM, and the other is ACFM. A standard CFM is a mass flow rate, so it's 0.075 times 400, or 30 pounds per minute per ton, right? But if you scroll down a little further in there, Brian, and there's some like footnotes, you'll see that there's air density calculations. And so with an ECM motor, what will happen is you'll move more actual CFM when the air density is low to actually achieve the standard CFM that we need across the coil.
Right.
So it's really, it's quite cool when you start looking and understanding all this stuff, because we really don't cool CFM air, we cool pounds of it.
Right.
And so MeasureQuick takes all those things into account.
Yep, and then we've got all sorts of more in-depth things, which we're not going to go into right now, like enthalpy and bypass factor, which are all fun. I mean, we could do a whole podcast just on this little additional information down at the bottom, and we will. We shall do that. Actually, that's perfect. Let's do a podcast on this additional information segment here. We'll do that. But let's talk quickly about temperature split versus target temperature split, because this is one that a lot of technicians focus on.
Yeah, so in MeasureQuick, we're constantly calculating the target temperature split on there, and we do it actually a little bit differently than your typical temperature split table, because a standard target temperature split table just takes is under, again, AHRI conditions. So when it actually gets cooler outside, we can actually get a little bit more a higher target temperature split out of the machine. When it gets warmer outside, when the liquid line gets warmer, it's going to be less, because if you think about, like, if it's 100 degrees outside, you have a very hot liquid line, and now you got to take that hot liquid when it goes to the metering device and it goes to flash gas, and you got to cool it off, and to get the rest of the liquid down to the saturation temperature and actually lose a little bit of capacity. And so we account for all those variables in MeasureQuick. So when you're profiling the system, and you tell us that it's a 13 SEER or a 6 SEER or whatever you're telling us, that actually goes into the target temperature split calculation. So it's a bit more exotic than what you're going to find in a regular target temperature split chart, and that's why sometimes it'll be different. And so what we're trying to do then is we're trying to get the target temperature split as close to the actual temperature split as possible. And what's really slick is it's really not hard to nail those numbers, because most of the time we're removing humidity, so we actually have quite a bit of believe it or not, because that latent load in there, it actually locks those numbers in pretty solid. So you want to get your actual airflow as close as you can to the target temperature split, and that's going to give you the correct airflow across the system and the correct latent sensible split on the machine, and it's going to optimize your performance. So really important to do, because we calculate that target temperature split, but in fact, the charts you might use are all based on 350 CFM or 400 CFM per ton. We adjust it for, if it's 350, it's 400, 450. We adjust it for the SEER of the machine. We adjust it for the outdoor air temperature. So there's a lot to that calculation that makes it all work.
And it'll only get better, because MeasureQuick is based on this idea of big data. As we get more and more, as you get more and more of this data entered, you'll be able to make finer and finer tweaks to it to get it even better than it is now, which it's really, really good now.
Yeah, and there's even more interesting things, like we're trying to make, some guys we found out just recently doing package rooftop units. They hired a bunch of young guys, and they were putting the liquid line probe on the discharge line. So now we have, we can sense that in MeasureQuick, because that messes all the calculations. But you don't think about those things until you start to look at bigger data and why people are getting weird readings out of your software.
Yeah, one question I get all the time, which I never really have a great answer to, is that what's the difference between liquid line pressure and discharge line pressure? And I just
11 pounds.
Is that a real answer, or you're just making that
up? about 10 to 11 pounds. Yeah, it's because you got pressure drop through the condenser coil. So if you were to look at a carrier system, a lot of times carrier systems on the package rooftops, they actually have discharge pressure, and you'll notice that they actually run about 17 degrees of subcooling. And if you just took a standard unit and you say, okay, if you were to like measure the subcooling at the liquid line, if there was a pressure port there, you find out it's running about 10 degrees of subcooling. And so what that is it's accounting for the pressure drops of the condenser coil.
So they're
And
actually expecting you to measure it on the discharge line.
Yes, they are. Yep.
Got it.
Yep. Because that's the only place they got the pressure port.
Got it. Yeah, that makes sense. Yeah, and so, but again, as we gather more and more of this data, it's going to be easier and easier to give exact answers, even depending on a specific piece of equipment. I wanted to ask quickly, because somebody mentioned it, this return face velocity. I assume this doesn't show a number because we didn't enter the size of the return, correct?
Yeah, well, that's going to come in here. I don't know if we're calculating in your version of MeasureQuick or not, but it will be in the version we release this week. And it takes calculates basically, you put in your filter size, it figures out the square feet, divides it, and then using the CFM number, calculates your filter face velocity, which is a huge problem. When we're talking about all this COVID stuff, we're just talking about how important filtering in the air is. And a lot of filters are running way over 300 feet per minute of face velocity, which is where they should be, and they're running up in the 700 plus range. So most of you guys out there are going to find out you need about twice the number of filters that you have on the system. It's going to be very, very common. You're going to figure as you go through this, you're going to see, okay, we need 2 times the filtering because we got to cut the face velocity in half, and that will cut your noise down. It's going to really, really improve air filtration in the house, and it's going to make that system run a lot better.
Yeah, it's not just a matter of high static pressure. It's also a matter of the filter can't do its job when the face velocity is too high or when the velocity of the air across the filter media is too high. It has to be moving at the right velocity in order to meet the rated specification. Something a lot of guys don't think about. All right, so I want to now, again, we're gonna do another one on this. I think I may actually go live again tomorrow because I was really excited about this new call-in software. I may go live tomorrow and just take some questions from people using the same interface. We'll see what we can come up with. But I wanted to show quickly when we take all this data, because this is something that, because people are asking, well, what do your technicians do? Like, we're getting better at doing the reporting and projects and all this, but this is one thing my techs do a lot, and that is they hit this plus button, they save a snapshot. So you've watched what I'm doing here. They save a snapshot, and then they go to View Measurement Saved. And now this is where you can do something really interesting that I really like. I love this report. You hit Share, and then you export as a PDF. And now that gives you the ability to see all of this data on one screen. And it's really a nice report. It's a report you could, send to the customer. But I love it as something that you can share around the company, because you can also see, you see here, we don't show any icons of Bluetooth connected tools, but when you have the Bluetooth connected tools, those all show up, as well as anything that's calculated. And you can see all of this information on one screen, as well as where it was taken, site information, all that. This is really one of my favorite things in MeasureQuick, is this snapshot report. And to me, rubber meets the road. We people will ask, well, how do you do a system commissioning? Well, we just showed you, right? We just showed you based on MeasureQuick. You can go through the actual screen that shows the targets and whether you're in range and whether you have the, the green, hey, you're all good or not. But this is ultimately the report that's going to show you everything, and things like your capacity calculations. Really, that's rubber meets the road. That tells you whether or not the equipment is doing what it's supposed to do or not.
And once you get this down, it literally takes. The key thing is start the equipment first, so it's stabilizing, and then take a few minutes and start filling out the report. And literally about the time the equipment stabilizes, you'll have all the data filled in for the report. It's not that hard. So typically, you might spend half an hour to 45 minutes on your first one, but after you get it down, it's literally 10 minutes to enter all the data. And this is really the data you need to test the system anyway, and it's really the data you should be recording when you do a commissioning document, so you have the information you need for warranty, for your customer, for your company. It's really important to do that. And pretty much what you showed, everything on there is free. So there's, you can use this and take full advantage of it without spending a dime on MeasureQuick. Although we would appreciate it if you'd spend a dime.
At least one dime. Reagan reminded me
Yeah.
that tomorrow is Mother's Day, and of course I knew that. But what would your mother love more than for you to learn more about MeasureQuick? I mean, that to me is just an obvious thing. So quickly, I wanted to mention, for those of you who haven't seen this before, you have this flag up at the top right. That's really what's going to tell you whether there are any system-wide issues. If you get the black flag, that's a critical problem. Caution triangle, red flag, yellow flag. But where you're really looking to get that green flag, and just because you have a fault, especially like the yellow flag, that doesn't mean that there is a problem. It just means there's something you need to look at, and it's going to tell you what that is. And for newer technicians, that's great. Also, once you get everything dialed in, this is where you would go and then set your benchmark. And then in the future, say you came back to this piece of equipment and you didn't want a technician hooking up gauges, because in this, on this report, what did we do? We connected gauges or probes, hopefully. We took a bunch of temperatures with supply and return. I mean, those are the main things that we did. A regular, field piece job link kit, a couple manometers. That's going to do this job. But now when you go back, you don't always want to hook up gauges to the equipment and run the risk of losing some refrigerant. So you can use those benchmarks in order to do a non-invasive report next time, or a non-invasive project. So I'm going to go ahead and this is where I get a little confused here. If I go up, okay, here we go. So now I can do a non-invasive cooling report and pull in that data from the cloud previously and not have to enter all the same things again. And I can test the system without the need to connect gauges to it every time, which is also pretty rad, as the kids today often say. The kids say rad today? I think so. Okay, maybe in 1995. No, they don't say that? Okay, well, fair enough. So, did I cover that okay? Did I make any mistakes?
No, I think it was good. Yeah, I think we got the bulk of it covered. I think that's all good. There's a lot more we could cover on really leveraging the cloud stuff and storing projects in the cloud. The biggest thing is just download the app. It's a free app, and play around with it a little bit. You can mess with the demo data and see how all the things work. And we've got Bluetooth tools, Testo, Field Piece. What is the other one? Not CPS. UEI. What's
UEI.
Alpha make?
Yep.
UEI.
Yep. And I like the UEI air probes. A lot of our technicians use the UEI air probes. They're nice, especially in our market where we've got a lot of ductboard, and it's a smaller, thinner probe.
Yeah. So there's you can play around with it, see what you like, and go from there. So there's the risk in this is pretty low to actually get a lot out of it. And we've got over 25,000 people that use this on a pretty regular basis, and it's growing exponentially. So, and you'll see the software, continue to improve as we go.
Yep, and I just turned on my probe that I have sitting here. You can easily map everything. You can easily zero it out. I mean, it's so easy to use. I find in a lot of cases, I'll even just open MeasureQuick and take it to this toolbox screen just to get a quick reading off of something without having to go to the native software, just because it works so smoothly. They're always making improvements to the software. I love it. It's great stuff. And when Jim first started talking to me about this stuff, I don't know how many years ago it was, I wanted to believe in it, but I thought, man, this is going to be a big undertaking. But by golly, Jim, you've built it. Congratulations.
Well, actually, a whole team of people built it.
Okay, fair enough.
I just got to drive the ship a little bit. So.
Yeah, that's nice. All right, great. Well, thank you so much for taking the time to do this. We are completely out of time to do anything in addition to this. I'll get with Jim and we'll do some more Q&A follow up. I know a lot of you are going to want to ask some more questions about this. Sorry about the technical difficulty. You're going to love the new software, though. We can take live calls and all that, and it'll be great. Just had some issues with it today, but yeah, that's MeasureQuick. This is how we do commissioning of equipment. This is what it takes to do a proper commissioning, and it really involves everything from airflow to electrical to refrigerant side readings. At the end of the day, you get that real capacity, look at capacity, which ultimately is what we want to know. Is the thing doing what it's supposed to do? Is it moving the air it's supposed to move, and is it removing the BTUs that it's supposed to remove? So there you have it. Anything else, Jim?
Nope, that's it. Thanks for the time, Brian. I enjoyed it.
All right. Thank you all so much for watching. I appreciate you as always. You can find out more about everything we do by going to hvacrschool.com. This will be up on YouTube as soon as it's done processing and trimmed and all that, so you feel free to share it with your friends. I encourage all of you to go out, use the free version of MeasureQuick, but then also when it comes to the point that you can use it within your businesses and you pull down that data from the cloud, hopefully you see the value of that and support what they're doing, because they've spent a lot of time building great software that we've all benefited from. So support them where you can. Again, Jim and I have a friendship. There's no monetary exchange here. If somebody sponsors us, we tell you this is not a sponsorship thing. This is just a good friend who built awesome software. It's really helped the industry a lot. So yeah, thanks so much for doing it, Jim, and we'll get together soon and cover some more of this.
All right, sounds great. Appreciate the time, Brian.
Thank you. All right, thank you, everybody. Have a wonderful evening, and we'll see you again very soon, even with better streaming experience on the HVAC School podcast.